Hey guys, welcome back. This is going to be example 2 for section 2.4 for Algebra 1. So what we're looking at now is we have variables on both sides. So this section comes at you quick and it comes at you hard. We had to go through the top part of it where it's just extra steps on one side. And now we're looking to have variables on one side. So if you remember in chapter 1, they actually broke it up into two sections. We're expecting you to know how to solve higher order equations now. So anyone that was in my class that's looking at this, you can apply your 4 steps. Distribute, combine like terms, get your variable on one side by addition, subtraction, get rid of everything else by addition, subtraction, all other terms. And then the 4th step was get the coefficient, get rid of the coefficient through multiplication, division, or both. And you'll see what those mean. You should know what those mean as they come up. But remember, just like before, when we had variables on both sides, we have a unique opportunity here for a lot of different solutions. The first solution is the typical solution, which is what's been happening all the way up till now when you're working with inequalities. You'd have open and closed circle, and then part of the number line is shaded in. You can also have 2 other opportunities come up now. You can have nothing works. So all that means is I presented you with an inequality that can never happen. No matter what number you plug in, this side can ever be less than, greater than, less than, equal to, greater than, equal to the other side. It cannot happen, which is fine. It just means there is no number to solve this problem. And then you can have inequalities that every single number works. So you'd have infinitely many solutions, which means all real numbers work, okay? So when you're working on these now, when you have variables on both sides, typical, your normal ray that gives you your dot and the ray going in one direction. No solution, which means you'd have your empty set and you would end up with a false statement, like where you'd have 4 is greater than 10. So if you solve something like that and the variables dropped out, then you know that you have no solution, which means you would not shade anything on the number line because none of the numbers work. You could have where you get something like 6 is greater than 2. Well, that's always true. And if that happens, then every single number is a solution and you would shade in the entire number line. Okay? So let's just start looking at some of these problems. The first one is 6x minus 5 less than 2x plus 11. I'm actually going to go to my hover cam for this because the steps that I told you guys to solve for this are different than how the book does it. I'll go through the book steps, but I want to show you guys the way I've been doing it in class. Sorry for the line through here. So I look, no distribution, no combined like terms, no distribution, no combined like terms. I want my variable on one side. I'm going to get rid of that 2x. So I'm going to subtract 2x from here. I'm going to subtract 2x from there. I'm left with 4x minus 5 less than 11. Now I want to make sure my variables on one side, get rid of all terms on this side. This is what I'm getting rid of. I'm getting rid of that term. To get rid of a minus 5 is plus 5. Those are gone. I'm left with 4x is less than 16. My final step now, I'm going to get rid of the coefficient. It's x times 4, so I'm dividing by 4. That leaves me with x less than 4. And now I just need to put it in on a number line. So this would be considered a typical problem because we just have a typical inequality. So I'm going to go up here. I'm going to use this one. There's 0, there's 2, there's 4. So I put my circle above 4 or on 4, however you want to do it. I always do it above. I leave it unshaded because it is not equal to. X is less than 4. I'm shading in all the numbers smaller than 4. These are all the numbers smaller than 4. So I shade to the left. Okay. So this is the first part of this, and then I'm going to come back in a later video and show you the